page 283 in your textbooks, and you had just 4 problems for homework. Page 283 to 284, numbers 21, 25, 26, and 27. I have those 4 problems out. Using a little bit of order of operations with matrices, so making sure we followed those, and then a little bit of back and forth with addition, subtraction, and multiplication of matrices, so a chance to work all different processes kind of mixed up in there. So 21, 25, 26, and 27. Bueno. See y'all. Get my microscope out. Good. All right, let's take a look at these together, see how we did. Number 21, just multiplication. So we're going to start multiplying the 2 by 3 by the 3 by 2, and that'll give us a 2 by 2. Then we multiply the 2 by 2 by the 2 by 2, and we get a 2 by 2. What was your 2 by 2 answer, though, Maddie?
Negative 18, negative 7, 14, 5.
How many had the same answer as Maddie? Negative 18, negative 7, 14, 5. Okay, well, let's take a look. The first multiplication, of course, is the 3 by 2 and 2 by 3. Excuse me, 2 by 3 and 3 by 2. And so we have the 2, 1, 4, 3, 0, negative 2. And it should have given us a 2 by 2. So check that first. See if this is where the mistake was. Let's see, partial products of negative 2, 0, 0. And negative 1, 0, negative 6. Negative 6, 8, 0. And negative 3, 6, 2. So let's see, that's a negative 2, negative 7. I really wish the book had the answer in here. This for your first 2 by 2. All right, were we good on that part? Okay, and then we had to take that answer and multiply it by the next 2 by 2, which was the 2, 0, 2, 1. Again, that's going to produce another 2 by 2 matrix. Let's see, that's a negative 4, negative 14, 0, negative 7, 4, 10, and 0, 5. And that should be negative 18, negative 7, 14, 5, which is what she had said. Did we find her mistake? If we did not get it, did we find the mistake? All right, questions at all on number 21? All right, 25. Now, if you're really, really lazy, like a real mathematician, and you remembered I accidentally put that on the board yesterday, and you went back to the YouTube video last night and copied it. Hopefully you didn't do that. Well, hopefully we added first, right, on 25. Added to get negative 1, 3, 0, 0, and then multiply that by the 0, negative 4, 1, 1. And that'll again give us a 2 by 2 sum. So what is that? 0, 3, 4, 3, 0, 0, 0, 0 to get 3, 7, 0, 0. How many had this answer on number 25? All right, did you find your mistake? Did not find a mistake. All right, check your addition first of all. Inside the parentheses, we've got that addition. Did you get this? When you added the matrices together, what was your sum matrix before the multiplication?
A negative 1, negative 2, 0, 0.
Okay, somehow it ended up with a negative 2. Okay, all right, lovely. Let's see, number 26, similar, right? We're going to add the latter 2 matrices together, 7, 6, negative 5, 2, and multiply that sum by the 2, 1, negative 2, 0. First of all, how many had the correct sum? On the back half there.
I did it all in my head.
You did the whole thing in your head?
Well, except for the end.
Oh, wow, that's mildly impressive. What was your answer?
9, 14, negative 14, negative 12.
That's really impressive. If you did the whole thing in your head, that's remarkable. That is correct. How many had the same answer as Abby? 9, 14, negative 14, negative 12. All right, I've always said one of these days I'm going to have a student that's smarter than I am. I might have found her. I'm still a teacher though. And Janice is like, we'll just go home. Come on up and teach Abby. Just kidding. Great job. Wow, that's impressive. Anyone need to see the multiplication step? And we need to see the multiplication. You got this sum, but you didn't get the answer Abby said a moment ago. 9, 14, negative 14, negative 12. Yeah, let's take a look at the multiplication here. Again, check partial products. 14, negative 5, 12, 2, negative 14, 0, negative 12, 0. And that should give us, 9, 14, negative 4, negative 14. Not negative 4. I just never got around to the one. Yeah, so 9, 14, negative 12. Checking partial products, was that the problem? The partial product's the problem? Okay, that's alliteration. Mrs. Henderson would be proud. Questions 26. All right, 27. What has to happen first, order of operations, class? The multiplication's got to happen first. And that first matrix, what are the dimensions of the matrix, Michael?
3 by 1, 1 by 3.
Well, the first one's 3 by 1. The second one's 1 by 3. What would we call that first matrix, class? Column matrix. The next one's a row matrix. And the final one that's being added is a
Square.
Now, it's important. You can only add matrices if they are exactly the same size, right? So the 3 by 1 and 1 by 3 is going to give us a 3 by 3 square matrix, so we can add the other 3 by 3 square matrix. Nice thing is the multiplication is actually really straightforward here, but I'll show it anyway. Right, because you're simply going to take this, drop it down all of these, and that's going to give us the top row, right? Negative or positive 3, negative 15, negative 21. Then we're going to take this value, distribute it, which of course gives us all the same values. Distribute this gives us all the same values. How many got this for the product matrix first? Okay. Again, sometimes you have so few numbers, like surely there's more to it. No, it really is taking the first row, which happens to be one number, and drop it all the way down the first column, like the whole thing, right? Just one value. Then go all the way down the next column, get all the partial products, all one of them. And then all the, again, there's only one thing, so it almost is too easy to be easy. Question?
I did all that. I just set it up as a column.
Say that again. Let me look at your work so I can understand what you're saying. Oh, okay, so instead of saying this item, then this item, then this item, you put these three together in a column. I gotcha. Okay, and again, that's where taking just a quick moment to say, okay, this is 3 rows, 1 column, 1 row, 3 columns. That tells you 3 by 3. If you set that up first, set up your little tic-tac-toe board, that'll help you to picture what goes where. All right, does that make sense? Mm-hmm. All right, so then we're going to take the 3 by 3, which was important to be 3 by 3, add to this. And again, when we add matrices, you're just adding corresponding elements. Remember, each number is called an element in the matrix. And what did you get for your final answer here, Kendall?
4, negative 10, negative 20, negative 3, 5, 9, negative 1, 4, 8.
Good. 4, negative 10, negative 20, negative 3, 5, 9, negative 1, 4, 8. How many had that final answer, 27? All right. Genesis already found her mistake. Maddie, question? Did you get the correct product? Or, yeah?
I just multiplied.
You multiplied these together?
Just one of the numbers.
Okay, gotcha. Instead of adding, multiplied one of them. Okay. All right. Any questions on that? By the way, if I named this matrix, matrix Z, for instance, what would be the name of this element right here, class?
Lowercase z.
Good, lowercase z, 3, 3. What would be the position of the 5 in this matrix, class? Z, 1, 2. Yesterday, we began talking about a matrix, which if I multiplied another matrix by this matrix, the answer would be the original. Nothing would change. We can multiply a matrix by a matrix, get exactly what we started with. What do we call that matrix by which I can multiply something and still end up with the exact same thing? Audrey? Brandon?
Identity.
Good, identity matrix. And we said there's not one identity matrix. There's literally technically an infinite number of identity matrices. And it all depends on how big the original matrix is. For instance, if I had... I don't know, 3, 2, 5, 7, 1, 4, negative 3, 8. Well, this matrix here, class, is a 4 by 2 matrix. Well, I would have to multiply this based on the number of columns, remember. I have to multiply, if I were to multiply by the identity matrix, I'd go with the I2 matrix. What is the I2 matrix? Do you remember this now? Now that he said identity? Do you remember what the I2 matrix is?
1, 0, 0, 1.
Good. Yes, what you said, not what I started to write. 1, 0, 0, 1. And we said there's, again, an infinite number of identity matrices. If I happen to have a 2 by 4, then I would do an I4 matrix. This doesn't exist. Imagine I had a 2 by 4. Okay, well, what would the I4 matrix look like? Michael?
1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1.
There we go. Remember, this line right here from top left, the very first element, all the way down to the very last element would all be ones. Everything else is zeros. What do we call that row of ones? It has a name, those elements in that order. Anyone?
Main diagonal.
It's called the main diagonal. So the main diagonal is going to be all ones. Everything else is going to be zeros. And then we multiply the matrix by the appropriate identity matrix. You just get what you started with. We also talked about things that cancel each other. For instance, a 5, if I add to it a negative 5, they cancel. If I have a negative 17, I add to it a positive 17, they cancel. We would call those numbers class inverses, right? Specifically additive inverses, but inverses. And we'd looked at additive inverses before. For instance, if we had a matrix M and we were subtracting a matrix R, for instance. Well, I said what we'd really do is we'd find the additive inverse of R, change all the signs in the matrix, and then we would add it together. So we've looked at the additive inverse for matrices. We also looked at this, the multiplicative inverse. Now with regular numbers, for instance, 7 would have what multiplicative inverse class? 1 is 7. Where it doesn't cancel to give you 0, it cancels to give you 1. Well, for matrices, this is where we left off yesterday. If matrices are multiplied by a multiplicative matrix, a multiplicative inverse matrix, then it's not going to give you 1 necessarily, but rather, class, it's going to produce, what? You can look in your notes if you need to. An identity matrix. If you multiply a matrix by its multiplicative inverse, you will get the identity, or an identity matrix. Remember, we said normally multiplication with matrices, not commutative. But with inverses, multiplicative inverses, you could do it commutative. In fact, both ways you'd multiply, first times second or second times first, would produce an identity matrix. Look at page 284, if you would. I think we're there anyway. Drop down to number 37. Number 37. And the instructions at the top of this section tell us to do what here, Genesis?
Determine if the matrices are inverse.
Determine if the matrices are inverses. Well, they obviously aren't additive inverses, right? Additive inverses would be the exact same thing with all the signs changed. But they might be multiplicative inverses, and that's what it's asking for. So we have a 1, 3, 5, 1, 4, 7, 1, 2, 2. And if 6, negative 4, negative 1, negative 5, 3, 2, 2, negative 1, negative 1 is the multiplicative inverse, then I would end up producing which matrix, class? I3, the I3 identity matrix, right? It's a 3 by 3, 3 by 3. It has to produce a 3 by 3. All identity matrices are square matrices. So the question is, when I multiply, do I get the I3 matrix? Well, let's run through some numbers here. We'll take the top row, remember, and drop it down the first column to get our first set of partial products up here. What is that first set of partial products going to be, Audrey?
6, negative 15, 20.
Now, I'm lazy. I am not going to go through the whole multiplication process. I'm going to go one element at a time, and if I come across even one thing that makes it not an identity, I'm done. I already know they're not multiplicative inverses. Does that make sense? Instead of doing the full thing, I'm too lazy for that. So what would the number be in this first element, element 1, 1? It is a 1. That's what I have to have right there for an identity matrix, so that means I have to keep going. All right, now let's drop it down the second column. What are my partial products, Abby?
Negative 4, 9, negative 5.
What does that give me?
0.
Okay, well, I needed a 0 there. Let's keep going. Let's go to the third column. What are my partial products now, Genesis?
Negative 1, 6, negative 5.
And what does that give me?
0.
Okay, we're still on the right track. So they still could be inverses. I haven't found a reason to say they're not. So let's go to the second row now. Go down the first column. Kendall, partial products.
6, negative 20, and 14.
And what does that give me?
0.
Okay, still so far. All right, the next number's got to be a 1, though, not a 0, right? So let's go to the next column here, Michael. What are my partial products?
4, 12, 7, negative 7.
I'm going to say, yeah, negative 7, and
1.
it is a 1. Okay, so I'm beginning to feel like these probably are. Let's go to the last column, drop it down, Maddie.
-1, 8, -7.
And sure enough, that's a 0, okay? And then finally, the bottom row, going down the first column, Brandon.
6, -10, 4.
Still on the right track, that gives me 0. All right, let's go to the next column, Audrey.
-4, 6, -2.
That's still a 0, all right? So it all hinges on the last number. If it comes out to a 1, what do we get, Abby?
-1, 4, -2.
And sure enough,
1.
does that mean they're multiplicative inverses? Means we're halfway there. But to be true multiplicative inverses, they have to not only produce the identity matrix multiplied this way, I'd have to be able to switch them. So let's switch them now. Let's start with a 6, 4, -4, -1, -5, 3, 2. Wouldn't you hate to do a copy error right now? 2, -1, -1. And try multiplying it by 1, 3, 5, 1, 4, 7, 1, 2, 2. By the way, as you look at these, do you see a numeric pattern that would make you think, oh, I bet these are inverses? I don't. I mean, I'm always looking for shortcuts and ways to cheat the system, and I'm like, I don't see a pattern at all that would indicate to me, oh yeah, of course these are inverses. So, okay. Once again, question is, do we get the I3? Genesis, will start with you. What's my first set of partial products?
6, 4, -1, -4.
Yeah, negative 6, -4, -1, and that gives me
1.
all right, down the next row, Kendall.
18, -16, -2.
That's a negative 16 out of 76. That could really confuse the situation.
0.
0, okay. And the next set, Michael.
30, -28, and -2.
And sure enough, there's a 0, Maddie. This should be easy.
-5, 32.
Yeah. That 1, 1, 1 does help, doesn't it? The next one, next set, oh yeah, and that gives me 0. Brandon?
-15, 12, 4.
Wouldn't it be amazing if we got to the very last one and it messed it up? We did all that work. Anyway, it's -15, 12, 4.
1.
That gives us the 1. All right, and then the last row, or last column for the middle row, Audrey.
-12, 25. 21 and 4.
And yep, that's a 0. All right, we're to the last row now, Abby.
2, -1, -1.
That was like insulting your intelligence. Take the next one.
6, -4, -2.
And of course, both of those are 0s. And we come down to the last one, Genesis.
10, -7.
And sure enough, it's a 1. So, are they or are they not multiplicative inverses? Class? Yes, they are. No matter which way you multiply A and B, they will produce the identity matrix. Let's go to number 38. Now, these are not square matrices, are they? What are the dimensions of the first class?
2 by 3.
2 by 3 and the second?
3 by 2.
Can you multiply a 2 by 3 by a 3 by 2?
Yes.
Yes. Could you, in just a moment, multiply a 3 by 2 by a 2 by 3? Also, yes. Now, in this case, if these multiply to give you an inverse as inverses, which identity matrix would they have to produce?
I2.
An I2. Here, if we multiplied, they would have to theoretically produce I3. Right, so it's going to be different identity matrix depending on the multiplication, but they are capable of being inverses. Is a 4 by 5 capable of being an inverse of a 5 by 2? No, because although you could multiply this way, if you tried to reverse it, you couldn't, so they can't possibly be inverses. Does that make sense? In some cases, you can rule out the possibility of multiplicative inverses before you even start. That's what I was trying to do, but it didn't work. They could work. All right, so let's go ahead and start with the initial multiplication. And let's try multiplying A by B in the order given. So 1, 3, 2, and -2, -3, -3. And 0, 1, 1, 1, negative 1, negative 2. Again, I don't really see a numeric pattern that makes me think, oh yeah, of course this is going to work. So, I don't know. All right, we said it's going to produce an I2. So, set up just a single crisscross grid here. And Maddie, partial products.
0, 3, negative 2.
What does that give us, class? 1. So far, so good. Next box, Kendall.
1, 3, negative 4.
That gives us
0.
0. Okay, still so far, so good. Let's go to the next row down the first column. What do we got, Abby?
0, negative 3, 3.
And that gives us, class,
0.
0. Okay, and then the last box here for this round of multiplying, Brandon.
Negative 2, negative 3, 6.
And that gives us, class, 1. All right, so far, so good. Now the reversal. Let's take the 0, 1, 1, 1, negative 1, negative 2. Try multiplying it by 1, 3, 2, negative 2, negative 3, negative 3. This time, we're going to get an I3, so it's going to be a 3 by 3 square. So tic-tac-toe grid. Move this out of the way, and we're to Michael.
0, negative 2.
Oh, what does that give us, class?
82.
Well, at least, sorry, there was supposed to be 9 total spaces here, but yeah, right off the bat, on the second round, first round looked like they were, are these multiplicative inverses? No, they passed half the check, but on the very first step of the second check, nope, they are not multiplicative inverses. Do we understand how to identify them and really hope you wouldn't have more than one of these on a quiz or test? Yeah, so be nice to the math teacher and the quizzes won't have more than one of these, right? All right, I do Reese's chocolate. Reese's chocolate's good. And Brecken and Gavin be like, he already sent us our quizzes, so we can't change ours. I'll send an amended one just for that. All right, go up to number 34. Number 34. These look nice and easy, right? They're little bitty, 2 by 2. And since they're both 2 by 2, no matter which way you multiply, we're shooting for what kind of matrix, class? The I2. One, two, two, 3, negative 3, 2, 2, negative 1. Now here do you see a pattern? I kind of do, right? The 2's are in matching positions, the 1 and 3 are in opposite positions in negatives, you know. I don't know if that matters because I haven't seen patterns before and they work. So maybe the fact that there is a pattern means it ain't gonna work. Well, first set of partial products, Genesis.
Negative 3, 4.
Next set, Audrey.
2, negative 2.
All right, so I'm kind of mentally doing the 1 and the 0. I guess I should have called that out. The next set, Maddie.
Negative 6, 6.
And then after that, Kendall.
4, negative 3.
And there's the 0, 1. Okay, so far so good. Reverse. Negative 3, 2, 2, negative 1. 1, 2, 2, 3. Okay, somehow it doesn't feel like it's taking as long as it did the first time. Do you feel the same way? Anyway, maybe it's just because it's smaller. First set of partial products. Bless you. Abby.
Negative 3, 4.
Okay, so it made it past the first round unlike the last time. Brandon?
Negative 6, 6.
Okay. Michael?
2, negative 2.
Okay, still good. And then the last set here, Genesis.
4, negative 2.
And sure enough, yes, multiplicative inverses here on 34. Questions on that. Do number 33. Number 33, matrices. At least they give you nice numbers. Several people getting their verdict in. There's two ways to look at it. It's like, maybe they're done fast because they're fast, or maybe they're done fast because they came across a number that didn't work, and they're like, oh, there we go, we're done, no inverse. Which one is it? Abby, you were first.
They are.
They are indeed inverses. Both ways you multiply, it comes out to the I2 matrix, so yes, 33, they are inverses. How many did have that as your verdict? How many came across a mistake that made them not inverses? We need to figure out why we did that. All right, do 35. 35. And that's where we stop. Now, as soon as we hit that 3 class, nope, we don't need to do any more. And frankly, if I had to pick, I'd rather them not be inverses so I can get done quicker. Right? How many with me? Lazy enough? Anyway, go up to 29, just by way of review. We've got a 0, 7, 3, 1. And the instruction is to multiply by the multiplicative, or multiply by the appropriate identity matrix. Obviously, in this case, which is the correct identity matrix, class?
I2.
The I2. Again, what is the I2 matrix, Kendall?
1, 0, 0, 1.
There we go, and I wrote it correctly this time. And so when we multiply, again, what are those partial products we're going to get? Rattle them off as quick as you can, Kendall.
0, 0, 0, 7, 3, 0, and 0, 1.
Good, and so what is our product going to be here, Kendall?
0, 7, 1.
Right, which again, should be exactly what we started with. That's the premise of the identity matrix. At your seats, for the practice sake, do number 30. Multiplied by the identity matrix. I know what the answer is already going to be, obviously, but just getting the practice. And then we'll finally move on. And again, all the partial products should work out to the same numbers that we
Did you
had.
say 30 or 32?
Thought I said 30. Which one did I do?
30.
I did 32. Anyway, I did say 30. Yes, 32. Well, anyway,
That's what they said.
so ignore those numbers, but your partial product should give you the numbers you started with. All right, lovely. Let's move on. Questions on identity matrix.
That was God telling you to move on.
What?
That was God telling you to move on.
Move on. Yeah, I agree. Page 294. Page no, not that Genesis. We want to pass. Page 294. Why don't you do 1 through 11 the odd? Page 294. 1 through 11 the odd. Like I always say in life, you lose some, you lose some. Okay, but if you finish early, do number 15. Yes, this be like, I'm taking my time now. Finished with 15 already, you can just sit there with a smug look on your face. And just about another minute or so to finish. They don't actually want you to multiply. They're just asking, can you multiply this way?
Yeah.
Okay, so it's like a yes or no. All right, let's go ahead and take a look at these together. Number 1, what did you get for your answer? Brandon?
1, 3, 1, 3, 3, 2.
Close. Audrey?
14132.
141,332 is correct. Number 3, when we add the additive inverse, or as it says, subtract, for redemption, what do we get, Brandon?
1, 2, negative 2, 0, 1, 3.
Good. 1, 2, negative 2, 0, 1, 3. Number 5, when we multiply that scalar, what do we get? Abby?
5, 10, negative 35, 50, 0, negative 5, negative 45, 30, 15.
Good. 5, 10, negative 35, 50, 0, negative 5, negative 45, 30, 15. Number 7, we had to multiply 2 scalars, then add the resulting matrices. What was your final answer, Genesis?
0, 11, negative 5, negative 4.
Good. 0, 11, negative 5, negative 4. Number 9, can I multiply those 2 matrices in that order? Maddie? Yes, you can. We got a 2 by 3 and a 3 by 2. Yes, you can multiply those if you can remember her name. Number 11, they wanted us to go ahead and multiply those matrices together. What was your product? Michael?
1, 1, 0, 1.
That is not what they had.
1, 0, 0, 1.
It is. It's an identity matrix. So what does that tell you about, well, what does it cause you to think may be true about number 11 class? They may be multiplicative inverses. Now, we don't know unless we turn around and multiply the other way, and I'm lazy, so I'm not gonna. But it makes me think they might be multiplicative inverses because they gave you the identity matrix 1, 0, 0, 1. For those who went on to number 15, are those inverses, yay or nay?
Yes.
Yes. They are inverses, yes. If you went through multiplied AB and then BA, they would give you the I3 matrix both times. So those are indeed inverses.
I thought they were
No.
All right. They weren't. Okay.
No, I had them as they were, and then I went back, and I thought I'd change the sign. And so, yeah.
Tears and sadness. Any questions on what we've talked about the past several lessons on matrices? Or do you feel like we've got this down pretty well? Do we feel nervous?
What?
Actually, 20 questions.
20 questions. All right, let's take the first one. What is the meaning of life? How about related to algebra class?
What's your name?
I mean, if you know this really well, like I think you do, I think this is a great chance to do a great job on a quiz and start the quarter well, right? If, however, we're like, oh, I'm really struggling with this, I mean, we could obviously postpone it to tomorrow and spend the rest of the time reviewing, but if you feel good about it, or do we feel good about matrices? Or do we feel like I really need more review because I'm probably going to blow this quiz bad? Anyone feel like terrified of this quiz? And how many feel like, I think I got it? How many are like, I just refuse to commit, I'm like a Democrat. No. All right, well, let's take the quiz then. Clear your desk except for a clean sheet of paper, pencil, calculator, always a good option. Sheet of paper, pencil, calculator, everything else away. Gavin's like, they never give me a choice whether or not to take the quiz. He just tells me, yeah, I know. No taxation without representation. It's just a quiz, Gavin, just a quiz. All right. Sheet of paper, pencil, calculator. First last name at the top of your paper along with today's date. Today is 3/30/22. 3/30/22. Today's date. 3/30/22. And this is quiz 29. Quiz 29. You need one, they need two. All right. Let's go take a look at the quiz together very quickly. Now Maddie has one, so now we can all look at the quiz together. Some questions for you there on 1 through 9. Answer the questions. Number 4 and number 5 are both referring to the matrix in number 2. Okay. Let's do the question. Numbers 10 through 13, if possible, do what it says. If for some reason it's not possible, just say not possible. Do we understand on 10 through 13? All right. There is no homework, so I'm going to end the video here and do well on the quiz.